Hello, good morning to everybody. Today I am going to discuss about the wireless transmission with the chapter 3 of mobile computing. So, wireless transmission means the transmission will occur without the wire medium. It will happen through the air medium, or you can say it will happen through the unguided mediums. So, this is the first we're going to study about the signals. What do you mean the signals? Signals is in electrical engineering the fundamental quantity of representing some information is called a signal. It does not matter what the information is. In mathematics, a signal is a function that conveys some information. That means signal, what do you mean the signal? Signal is the representation of the information, right? So it may be the analog signal or digital signal, right? Because data and suppose your information data is a hidden thing. How to represent that thing? Now this is the signal is one medium. It is the physical representation of that signals. And signals are two types. One is your analog signal, another one is your digital signal. First come to the analog signal. A signal could be an analog quantity, that means it is defined with respect to the time. It is a continuous signal, and these signals are defined over continuous independent variables, and they are difficult to analyze as they carry a huge number of values. So this is the picture, it is a continuous curve or it is a sinusoidal curve, right? And it is the signals are defined over continuous independent variables, and they are difficult to analyze because they carry a number of the values. It's a sinusoidal curve, right? Now, so this is the amplitude and volts, and this is the time period. And this is the continuous form of signals, and these signals contains number of the independent variables. That's why it is very difficult to analyze something. Alright, so and it is also, remember, it is a sinusoidal curve representation. It is a sinusoidal representation. Next come to the digital signal. A digital signal is a signal that is being used to represent data as a sequence of discrete values at any given time, and it can only take on one of a finite number of values. So that is the difference between the analog and digital signal. Here the analog signal, there is a continuous independent variable, and that and it contains a number of values, right? Number of the values. So, but in case of the digital signal, here at any given time, it can only take one of a finite number of values. That means this is the difference between the analog signal and the digital signal. Digital signal only represent a particular finite number of values. That means with 1 0 1 0 1 0. In this axis, the time axis, this is the amplitude. This one represented as the on, and this 0 is represented as the off. So this is that's why the digital signal, to analyze the digital signal is easy compared to the analog signals, right? So there are some terms regarding the signals, right? Suppose in the signals there is a what do you mean the period, right? Now period refers to the amount of time in second a signal needs to complete one cycle. Come to the analog signal, this is one cycle from this point to this point, this is one cycle, right? Now, so refers to the amount of time a second a signal needs to complete one cycle. How much time is required to complete one cycle, that is known as the period. Similarly, what is the frequency? It's another term, is the measurement of the number of occurrence of a repeated event per unit of time. That is the frequency. Frequency, again I am repeating, is the measurement of the number of occurrence of a repeated event per unit of time. Right? Unit of time may be second, may be millisecond. Within that period, within that period, the number of occurrence of repeated event per unit of time, that is known as the frequency. and it also can be defined as the number of periods in 1 second. Clear? You can frequency also you can define number of periods in 1 second. That means within 1 second how many types of events will occur. That is known as also the frequency. And also come to the here the period and frequency. Next is that your bandwidth. The range of frequencies that a medium can pass is called its bandwidth. The range of frequency that a medium can pass is called its bandwidth. It is a property of a medium, and it is the difference between the highest and the lowest frequency that a medium can satisfactorily pass. Clear? So bandwidth is another form. And thus hello, yes. So again, what do we mean the amplitude? The amplitude of a periodic variable is a measure of its change in a single period. So what do we mean the amplitude? The amplitude of a periodic variable is a measure of its change in a single period. There are various definitions on amplitude, you can say, which are all functions of the magnitude of the differences between the variables or extreme values in, right. So in the changes in the periodic values, it is known as the amplitude. So these are the factors also you can relate it with this signal term, analog and the digital form. So next, if you come to the antennas, what is the antennas? An antenna is a transducer or a device for converting energy from one form to the another for the purpose of measurement of physical quantity or for information transfer. So antenna is a device for converting energy from one form to the another and for the purpose of measurement of physical quantity or for information transfer. So there are two types of antennas. One is omnidirectional and second one is your directional. So antennas also it is known as the aerial, right? And it is designed to transmit or receive radio waves. Antennas are used in systems such as radio and television broadcasting, point-to-point radio communication, wireless LAN, radar, and space exploration. Antennas usually work in air or outer space. Antennas have practical use for the transmission and reception of radio frequency signals. So it is overly it is known as a device which is used to transmitting or receiving the signals. Clear? So they are divided into two types. One is your omnidirectional, second one is your directional antennas. Omnidirectional radiates equal in all directions, but where in the directional radiates more in one direction than the other. Right, so that is the difference. Again repeating, omnidirectional antenna transmits power in all direction, where directional antennas concentrates most of its power in one direction. So a directional antenna has more gain. It is defined as the ratio of the radiation intensity in a given direction to the radiation intensity that would be obtained if the power accepted by the antennas were radiated equally in all directions. An antenna's gain is expressed in the dBi form than the omnidirectional type and is capable of propagating the signal further because it focuses the power in a single direction. Long distance transmission require high power and directive radiation pattern. Wireless LAN and WANs are omnidirectional antennas and wireless MAN use antennas that are directive. So all things are dependent upon the whether we are using the omnidirectional or directional, depend upon your communication. Sometimes according to your communication factor you are using omnidirectional antennas. So omnidirectional antennas is a 360-degree antennas. That means it cover all the range, right? But the directional focus in the particular directions and the from the particular directional, so it is known as the directional antennas. So